Hi, I'm Yush Kocher, and this is my Lab 3 for Physics 2012 Magnetic Field of a Bar Magnet. The introduction. The purpose of this experiment was to conduct an experiment to measure the distance dependence of the magnetic field due to a bar magnet, to the Biot-Savart law to find the magnet moment, and to use the glow script code to create a computational model calculating the magnetic field due to the magnet. The findings of this lab were that the moment is 4.063 amperes times meter squared, and that n is negative 2.55. So these are the models and fundamental physical properties used in this lab: the distance dependence equation, the Biot-Savart law, and the natural log of the distance to dependence equation. The assumptions in this lab is that the bar magnet acts as a magnetic dipole with a separation distance much greater than the dipole distance, and because of this we can use the Biot-Savart law. So the system and initial conditions. The system in this experiment is the bar magnet, the surroundings is the Earth, and the initial conditions is that the net magnetic field inside the system is initially 0 before a magnetic field from the bar magnet is applied. So in this procedure, we use the magnetometer to find the magnetic north by seeing where the x component was close to 0. Then we found the location of the magnetometer chip on the phone by sliding the phone along a perpendicular line to the meter stick until it reached the position where the magnitude of the x component was the greatest and the y component was the smallest. Then the phone was rotated by 90 degrees, and this process was repeated, except the maximum y component magnitude was found and the minimum x component magnitude was found. So the observation that we noticed is that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in x direction, and that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So then the on-axis distance from the magnet to the magnetometer was found, where b of x was 20, 70, 120, 170, and 220 microteslas. And 3 trials were tested at each of these distances. These values were then plotted after taking the natural log to linearize them. So here's the data that was collected from, as previously stated, in order to graph the linear model. And so then to finish the experiment, the off-axis magnetic field was found by measuring the perpendicular distance for the field of 100 microteslas, and the phone was slid in the vertical direction with that same distance. Then the components of the magnetic field were found, and the y-coordinate was adjusted or corrected based off of the contribution from the Earth. So the calculations from the distance dependence equation, we were able to find that we were able to set the distance dependence equation, and then from there we were able to find that the n is equal to the slope, which is approximately negative 2.55. The distance r in our experiment was 1 meter, and then by isolating k in the natural log value, we were able to find that k is 8.126 e to the -7th. From there, we were able to find the value of mu by setting the Biot-Savart law equal to the distance dependence equation, and then when we rearranged and solved, we got that mu is equal to 4.063 amperes times meters squared. So here's my glow script code. What we did is we were able to find, we first set up the position of the magnet, and then I entered my magnitude of mu, and then to the right hand side we made a function that allows us to calculate the magnetic field of the dipole. Then what we did is we were able to scale the different arrows, and we were able to create observation locations at on-axis locations and locations that were perpendicular to the magnet. We then found we did that for all 4. Continued from there, we found the distance that was perpendicular to the magnet, and then we found the observation location, which was 45 degrees, and then from there we plotted this. And here you can see the final result of the glow script code, and at the bottom we have the printed values. So model comparison. With the experiment model, we got an average magnetic field of negative 4.4 e to the -6, 1.59 e to the -5, 1.47 e to the -6 teslas, and with the glow script model, we got a field of 3.357 e to the -6, approximately 1 5, 0 Teslas. And we can see that the magnetic field from the experimental model has a greater magnitude than the glow script model, and that discrepancies might have also occurred because the slope, which is calculated, was negative 2.55 instead of the expected value of negative 3. And so possible errors were the location of the magnetometer and that the phone was not oriented. So for the first what if question, the Earth's magnetic field would have impacted the X and Y components, and for the second question, the measurements were different because of the stronger magnetic field.